Hi everyone, I'm Michele Catasta. I head the AI team at Replit, and welcome to the third installment of the Replit AI panel. Today, as always, I have two guests, Amjad Masad, the CEO of Replit. Hi Amjad.
Hi. Hi.
And Jonathan Frankle is our special guest for today. Jonathan, I'll try to give an intro about the many things you've done recently. There is so much going on in the past month. I will pass over the mic to you, and you can fill every gap that I left. Okay. So Jonathan is currently the chief scientist at MosaicML. He has been leading the company research team towards creating amazing open source models. We're going to be talking about them today. Before that, he was a PhD at MIT. One of his main research claims has been developing the lottery ticket hypothesis, which won the best paper award at Clear 2019. And Jonathan, I know that you have a big news that you want to disclose. I feel this is a TechCrunch moment because it's the first time we hear it publicly. So I'm so proud of this. The timing was perfect. Please go ahead and tell us what's going to be your new job title.
Yeah, we're so excited that Mosaic has agreed to join Databricks. I think I have to say agreed to join because technically the deal is still subject to regulatory approval, and so we're not working together yet. Hopefully soon, though. If anybody here is at the FTC, we promise we'll behave. My mom worked for the FTC for 40 years, so
Oh, great.
I know that territory very well. So I will be chief neural network scientist at Databricks when all said and done, because we have to, at bigger companies, we need more adjectives. But, it'll be a lot of fun, and I'm really, really excited. This is definitely, I don't know, it means nothing for Mosaic except that we get to keep doing what we're doing, only bigger and better. So I'm incredibly excited to do even more great stuff.
That's awesome, and you can imagine how happy you are because we've been working with you for several months. So the fact that you're going to become even better at what you really do exceptionally is only a good news for Replit. So yeah, happy that we could break this news publicly today in front of everyone. Congrats for the new title, and let's get this started. So I think the goal for today is to talk about status quos in LLMs, especially the open source one, which everyone in this panel loves dearly, and also think about where LLMs are going in terms of both architectural improvements that we see in the short term and medium term, and also the impact that open source LLMs will have in the industry as a whole. I think, Jonathan, this topic is extremely relevant to you, given that you're going to be having even more people working on it since you joined Databricks. So let's bring the discussion there. All right, so why don't we start from our two flagship open source models, namely the Replit 3B model that we trained together and the recently MPT-30B, which I think has been released, a week ago?
Yeah. It feels like it's been it's been centuries since then, but yeah, a week ago.
Yeah, arranging a panel with you was perfect because I don't even have to think about what what should be the schedule. There are so many news on a weekly basis coming out, if not more. So we would have 10 hours instead of one in terms of chatting here. Jado, go ahead. Tell us more about the 30B. I think we want to hear why you're excited about that, and also what does it mean for the open source community.
Yes, the 30B, I'm really excited because honestly, we have a lot of little models now, but we don't have that many really big models. And, the cost of training one of these models increases approximately quadratically as you increase the number of tokens and the model size, etc. So it's a lot more expensive to train one of these big models, but they are more powerful. It certainly was a huge jump in all of the metrics we looked at. And I don't know, there are these beliefs, I've never really seen them validated, that bigger models reason better or bigger models, have capabilities that smaller models can't have. Quite frankly, I've never really seen that tested in a formal way. But for those who believe in that, I hope this provides a big commercially usable artifact for the community now. We don't have that many of those. We have the Falcon model that was awesome that came out recently. We have the Llama models, which are not commercially usable. So, I hope this is a step forward for everyone. We really pushed hard on long context windows, but by and large, it's just a bigger sibling of the MPT model, and I think that's the beauty of it. We trained a 7B model. We just let it sit for 10 days, and then the model was done. And then we trained a 30B model with the same code base. We just made the model bigger and let it go for a little bit. It took a bit longer because it turns out we have these amazing things called customers, and they also like to use our GPUs, so we had to kind of move around a bit. We love our customers, even if sometimes they take away my GPUs from research. It turns out having a business is a nice thing. And honestly, the coolest part for me, the thing that I contributed to this personally, was I got it up and running on the H100s, and we did some of our last bits of training on the H100s for long contexts. That was really cool. H100s are really fast. It was so much fun. I kind of described it to the team as going for a joyride on the H100s while they had just arrived. It was great. So, NVIDIA did it again, and it was fun to play with them.
And my understanding is that you could almost anticipate the release compared to what you had in mind, because the H100s proved to be even better, like beating all the wildest expectations that we all had. And that's also because like your team did an amazing job at optimizing and try to squeeze as much power as possible from that architecture. And also, I believe you just started at that, right? Like I think we're gonna be able to push even further the boundary with H100s in the next months.
Oh yeah, we got the H100s on a Friday, and I think we had the model training by Monday. I may not have slept during that weekend. There's a lot of software stuff to get figured out on the H100s, and performance is like the GPUs themselves are fast, but I'm sure that just like the A100 and the V100, given a few months, we'll have optimized the hell out of it. NVIDIA will have better drivers and better kernels, and we'll see performance get even higher. So I'm really excited. You know, it continues to shock me that the GPUs keep getting 3 times faster every 3 years or so, but it's really impressive. And just for fun, I trained a 500,000,000,000 tokens on our 7B model of additional data over the weekend, just for the hell of it, because the GPUs were
Why
idle
not?
and I didn't want them to waste. So that's the kind of thing that one can now just do. It means we all need to start dreaming a little bit bigger about the kinds of open source models we're going to have. It does mean the architectures need to look a little different. The H100 has a lot more compute units on it in parallel, which means you need wider layers to take full advantage of it. So I think the question that I'm thinking about a lot right now, and that we've got an intern who's doing fantastic work on this, Zach, trying to figure out what is the right architecture to take to kind of balance out taking advantage of the H100s and the new shape of the chip, and trying to get the best performance. Is it actually to do like a 6-layer, 10 times as wide transformer as opposed to doing a 24-layer transformer? Will that get you some combination of better performance such that, even if the model is a little bit worse, you'll be able to take away more steps and still get back to that performance? So there are a lot of questions there. And I think with new chips come new architectures. Even the original transformer was designed with TPUs in mind at that time, and TPUs weren't that great at RNNs. So they designed kind of a different parallel architecture. So I'm kind of excited what we'll do here.
Yeah, I agree. Like new hardware is unlocking new explorations of architectures, and I guess you guys are the first one to be able to do these ablation studies. We are all looking forward to see the results. We're also looking forward at Replit because we're going to be keep training models based on that framework. So absolutely. And the other highlight of the 30B is the 8K context size, right? So why don't we talk about that? Like I know usually bigger is better in LLMs in general, and also for the emergent behaviors that you were hinting at before, Jonathan. But also having a larger context window, of course, allows for much more power, but it comes at a cost. Maybe let's start from the downsides first of all, like how more painful it is to train a model with that context size, and then let's move to the benefits of having that available.
So you say it comes at a cost, but I don't think it does. And I want to be
Interesting.
more specific there. So what I'm going to do is I'm going to pull up in my other window here so I can read off some numbers, our throughput tables. Our throughput tables are public, so anyone can go look at these. But the reason why I want to look at them is because genuinely, as you get to larger model sizes, especially with flash attention, the attention operation is a relatively small portion of the overall compute. Attention is quadratic in the sequence length. So if you make your sequence length long enough, attention will again start to dominate. But as you get bigger and bigger models, attention becomes such a tiny percentage of what's going on that you can actually get longer sequence lengths for free. So what I'm going to look at right here, just for fun, is I'm looking at our 30B model. We did a little bit of profiling here. So I'm looking at a 30B model on 8 GPUs. This is 8 A100s because that's where we did the profiling with an 8K sequence length. And we're getting about 5,000 tokens per second. If you go down to a 4,000 sequence length, you're getting about 6,000 tokens per second. It's not a huge hit. It's 10 to 20%, if that. And if you go down to a 2048 sequence length, you're getting about the same. You're getting about 6,000. So just to go over that again, 2048 sequence length, 6,000 tokens per second, 4,096, about 6,200 tokens per second, and then 8192, you're getting about 5,000 tokens per second. There's a cost, but honestly, the cost isn't that big. The drop-off is much higher for smaller models because the attention dominates, relatively speaking. But as you get to bigger models, the matrix multiplies dominate, and so you kind of get longer sequences for free. If you're going to train a 30B model, you may as well do it at 8K. It doesn't really cost you much.
Is there any accuracy cost?
It's an interesting question. We haven't seen any so far. You're getting into the question of evaluation, and that is the thorniest question in all of deep learning right now. Because how in the world do you evaluate any kind of generative model? What is a good haiku versus a bad haiku? So the first thing I'll say is that we've seen with the 8K model, certainly doing training at 8K did improve quality overall. I don't know if we've done the apples to apples comparison of kind of same training time, but all 8K, so you get through less data, versus all 2K, where you get through a little bit more data. Only 20% more, but you still get through more data. I don't think we've done that work yet, but the evaluations tend to really be biased towards short sequence tasks. I think there's a great graph in our blog post about the 30B model where we showed kind of the proportion of data sets that was above or below 4K sequences. So, what fraction of the tokens in a data set were in a sequence of 4K or longer and what fraction weren't. The really popular data set C4 has basically nothing that's longer than 4,096. Everything is really short. That is also the data set that tends to do best on a lot of the in-context learning tasks, like multiple choice tasks and things like that. I don't think that means C4 is actually a good data set. I think it means doing well on those tasks. Those sentences aren't very long, and so you're biased towards short sequences being the best way to get there. That doesn't mean it's the best model, though. So I'm always worried about evaluation.
If you trained like a 30B with 2K sequence context length and 8K on the same eval, say it's still like short sequence biased, hypothetically you shouldn't get a performance hit.
I don't think so. I'd expect to see the 8K to dramatically improve real world performance. That's been kind of anecdotally my experience so far. It just remains coherent for a lot longer. And when you get to things like programming tasks where that may be necessary, it's really helpful. I would guess on a lot of the tasks that we typically use, like HelloSwag or Pika, these kinds of very common multiple choice tasks, I would doubt that an 8K window would help that much, simply because the model's not even going to be dealing with 8K tokens in practice on those tasks. It'll be dealing with like a couple hundred. Right. That's my guess as to why C4 does so well, even though by all rights it's a pretty old, bad data set.
Yeah. I mean, for everyone building products today, like most products with LLMs, the bulk of the engineering challenge is context wrangling, right? And to get to a place where we have to do less of that, we're going to see a lot more product velocity. And it seems like something people really want. The next challenge is like sort of the cost of loading up all these tokens on the GPU, especially if you have to do them over the network. I've heard rumors that, say OpenAI wants to do something like stateful, where you have a portion of the prompt is on the server, and so you don't have to pay the network cost. That would be great, but you still have to pay the inference cost every turn. Is that right? Or is there some way to kind of cache those on the hardware somehow?
So there's a little bit of this. I kind of want to break that question down into a few pieces. I'll answer this question first. Then you made a couple of assumptions that I disagree with. So in this case, you can do key query caching. So, when you suppose you've got a sequence, you've got the first characters and you generate the next one, you can cache all the attention for the first set of tokens, at least insofar as they attend to each other. So with each subsequent token, you only need to calculate a little bit of the attention, basically the outer row and column of the matrix. Mm-hmm. And so there is some smart caching you can do. Eventually you run out of memory, but this can reduce the computation pretty dramatically. You still need to do a lot of work to attend over the whole sequence to get the next token, but it's not as onerous as it might look because you don't have to do this quadratic operation n times and kind of get this n cubed operation. It is still n squared. Mm-hmm. And so things end up working a little bit better there. I do want to question the assumption, though, that it's just context wrangling. That, right now we do have to do context wrangling because the models literally don't support long context. We can't fit it into memory. But the next question is, can the models actually use long contexts? there aren't that many benchmarks that actually assess whether
Yeah.
you're taking advantage of the full, let's say, 64K sequence length that we had on our 7B model. Just because you have it there doesn't mean the model is actually using it in a meaningful way. Anthropic has done some nice experiments where they've tried to retrieve one piece of data from a long document. That's very different than holistically making sense of the whole document and making sure tokens can attend to each other. It's entirely possible that attention is still only focusing on one tiny part of the document. But I like the coding examples. If you're dealing with, let's say, you have an entire GitHub repo that you've put into your context to help you with generation, there may be many places in that repository that you have to attend to. And I'm not entirely sure that today's models, with the way that we structure attention, would actually take advantage of that to begin with. So having it is nice, but can we actually use it?
Yeah, I mean that's a really big question. There was one eval that I think someone at LangChain did, where they put Claude 100K versus GPT-4 plus sort of embeddings based retrieval, and basically GPT-4 performed better than the 100K context, or at least as good, if not better. That's my recollection. I can try to find it. But that was a retrieval task, and like you said, that's like a longer context length is sort of should support that, but that is not why we need a longer context length. It's about the sort of being able to do attention across the document is really where the feature becomes really compelling.
Yeah, and I don't know if we're there yet. I don't know how to know if we're there yet. I think that's the trickiest part. There are a lot of emerging long sequence benchmarks that people are proposing, but all benchmarks are flawed. And typically I would say, let's just do human evaluation. But doing human evaluation with a 64K sequence length, that's asking a human to read an entire book before they do a task. So that's it's tricky on that front. I'm honestly really excited about Replit applications for these long context models, specifically because you're going to get a lot of user feedback very quickly. Either users will take advantage of code completion or they won't, and you'll see the rates go up depending on whether you have a longer context. Eventually you'll be able to include, all of, a whole repo in there. Eventually you could even include like the entire history in there. And so there's a lot of I think at the end of the day, the users will be the judges of whether this helps or whether this hurts. It wouldn't shock me if it actually hurt. There's no reason to believe that if you give a model a long sequence, it will attend to the right things. So, a lot of cool scientific questions there, and I think you all are going to have the answers before everybody else does.
Yeah, the benchmarking stuff has been a little frustrating for us because, especially on the human eval, people are gaming it in all sorts of ways, including training on it, which is pretty dishonest. But just like we're not interested in that as much as we're interested in building a good product. For example, when the 3B that we trained, we did multiple A/B tests, and we got a net improvement of 50% over like Salesforce CodeGen, 50% improvement of real world use case of people accepting that suggestion, over and over again, better across multiple users, multiple use cases, multiple languages, and some languages in Python and things like that. That was way better. The average was 50%. The delta between CodeGen and our fine-tuned model. So we did multiple A/B tests as well between the base and the fine-tuned. And I think this is the kind of thing that that really tests these models. Evals kind of give you directionally, but they could also deceive you as well as people start targeting them directly.
Yeah, I think my take on a lot of the evals that are out there is they'll help you separate a bad model from a good model, but not give you clear distinctions among good models. I still haven't seen an eval that really gave me that much clear insight into which model I chose. Like even for the original MPT runs, I personally did this huge data set sweep. I tried a bunch of different data mixes. The end result was that they all looked the same according to the metrics. So I just kind of gave up, shrugged my shoulders, and said, let me choose something safe. If the evals can't give us that kind of resolution, they're not honestly that helpful. Whereas I'm guessing that, if you had done something similar for the Replit model and deployed it in the field, you would see some distinction. If you had changed the balance of the languages that you put in or what have you, you would have seen different popularity. And honestly, that's an experiment we should run at some point. We can do a little bit of fine tuning on the model. And I'd be curious to see if one plays with the data mix, does that affect the completion rate? And is there enough resolution there that you really have your gold standard metric? Because getting those gold standards is really tough.
The cheaper model training becomes, the more we will be able to afford testing on different checkpoints. I think that's the ideal world,
I'm
right?
here for.
You create a family of models with different mixtures, you put them in front of users, and that's how we found out what is the right mixture. Until now, we're just using common sense, and usually pays off. But the more we want to make the models advanced, the more I think all of us, we don't know exactly what we're doing. I think we're following a recipe of like best practices, but I wouldn't be able to justify how I actually build a mixture for the Replit model.
I wouldn't call them best practices. I would call them practices. I don't think there's anything good about them right now, which is, I mean, honestly, that's one of the most exciting things for me in the field. The best is yet to come, because clearly what we're doing is broken in so many different ways.
Yeah, I have to agree, unfortunately. What other improvements do we see? So I think we covered the data part. I think we all agree on that. Then in terms of maybe architecture, like what are some of the next developments in LLMs that you're excited about, and maybe that are gonna be landing in LLM Foundry in the next few weeks or months?
There's a lot of cool stuff coming. As always with Mosaic, there are, we test everything that we see. We test everything we read in papers, and most of it doesn't make the cut. There are a lot of cool things that work on really small models that don't work at scale. There are a lot of cool things where the author of paper may not have optimized the baseline as well as they optimized their own model. And the difference is really how much work they put into hyperparameter search, not the actual technique. We've seen this a lot. I think UL2 was actually one example of that, if I recall. Like, I know we tried it extensively and just could not get a benefit from doing it, no matter how hard we tried. It was very strange. But for us, I mean, we're looking at, there's some of the obvious low-hanging fruit, like, multi-query attention and things like that, which are, in fact, already in LLM Foundry. We haven't trained a model with them yet, but they're there. We've trained some small models, and it works great. So if, for those who are on the call right now, I know that's something you've been asking for a long time. It's there and ready to go. Playing with, again, optimizing architectures for H100s. I think mixture of experts in general has become really popular. Mixture of experts means many things to many people. Like, all these recent rumors about the OpenAI model and what it looks like, where it's really, an 8-way, 220 billion parameter. I wouldn't even call it a mixture of experts model. I would refer to that as, what's the word, an ensemble. I don't know, maybe, to pull some archaic terms out of machine learning before deep learning. But ensemble.
I'm feeling gold. Yeah.
Every winning thing on Kaggle is an ensemble. Like, honestly, it's a really good approach when you're out of other ideas, and I think that's, like, it's a fantastic choice. But going kind of core mixture of experts, there's a lot of opportunity there. The folks at DeepSpeed have demonstrated, I think things like a 3x or 5x speed up on pretty big models by going MOE. Palm has gone MOE. So I'm pretty excited about it. Getting the details right is really hard. Serving mixture of experts is really hard. I imagine OpenAI had a hell of a time serving GPT-4, even in this current form where it's really just an ensemble. If they had actually gone mixture of experts, that would have been an adventure. But we're always looking at things like lower precision training. Floating point 8 is coming. We certainly have models training and getting great convergence. We're still working on getting good speed up out of them, but that's a great special sauce for the H100. Low bit optimizers in general to free up more memory. There's a lot of other stuff we're playing with right now. But honestly, those are the things I'm most excited about. I think there's a lot of room to run here. And, any of those alone could be double digit or more improvements in training. I think mixture of experts could be more like 3x to 5x. But the devil's in the details, and getting this stuff working is the hard part.
And I realize I mentioned LLM Foundry before without explaining what it is. Perhaps, let me give you the mic again and tell us what it is. And actually, the reason why I love it is because now that most of the large companies are only releasing technical reports, aka marketing reports to an extent, I have a feeling that the LLM Foundry is going to become the standard de facto for state-of-the-art LLMs that we from the outside can read, go through the code, realize the choices that you guys have made through several ablation studies, and learn where the field is moving. That together with what Elutra is doing, maybe like a few other key players in the field, but that's where the state of the art of the open source is actually happening. So yeah, tell us what is LLM Foundry.
LLM Foundry is super simple. It's a GitHub repo. It has all of our LLM code in it. We do active development in the open on it, so you can see what we're working on if you go and look at the commits, even if it hasn't been documented yet. I think some people found, what was it? There was one feature, I think LoRa. We have LoRa support that we added this week. Someone found it like the moment we committed it. We still haven't announced it yet. We're still testing it, but someone committed it in. So, we have LoRa support, and someone found it. I wish they would wait until we really finish testing it, but it's there. And if you really want to go crazy, have at it. So it's an open source implementation of decoder only language models. It's really drop dead simple. The implementation of GPT-3 I think is still around 300 or 400 lines of code, and that includes all the distribution and everything else because we're using PyTorch FSDP. I hope it's easy. That's the most important part. Like at Mosaic, we make our money by providing infrastructure to help people train large models. We don't make our money by having secrets. So, we share what we do. It's all open. We open source a lot of our models because at the end of the day, we don't have a model we sell. We help our customers train models and they do whatever they want. Replit open sourced a model. Awesome. We have plenty of customers who don't even want to talk about the model they've trained and have it privately. That's awesome too. So LLM Foundry is kind of one embodiment of our commitment to open source, and we're going to stay committed. I really think there are only a few of us left. Replit is one of those companies. Eluther, certainly, the Allen Institute, and I'm hoping our friends at Meta see the light. And it sounds like they're kind of teetering on the fence right now of whether to embrace open source or not. And I hope they see the light and realize how much opportunity there is in doing so. So I'm hopeful that between all of us, we all have to kind of stick together. There aren't that many of us left, and we can't bother to do the research on our own. We don't have the resources, so we all have to work together on this. Certainly for my friends at the Allen Institute, my friends at Eluther, we chat all the time and collaborate, and it's been really great.
That's awesome. It's a great message actually. Like it would not be hyperbolic to say that so the future of technology rests on our ability to make sure that this technology is developed in the open. There's a world in which as software, as we believe at Replit, kind of increasingly becomes and revolves around LLMs and AI broadly, that it increasingly centralizes and becomes outside of the capacities of startups and SMBs and normal individuals to be able to have sovereignty over the kind of software that they want to build, and like we'll have more of a problem of sort of monopolies and really big central companies that control everything, right? So people think that right now we have this problem. If we end up in a world where AI is the sole product of a couple of companies, then we're really in trouble then. And so I think it's that's why we open source the model. That's why we contributed to open source. That's why we want the sort of open source AI effort to succeed is because the kind of world we want to live in is the kind of world where people can build these things regardless of whether you want to depend on a big company or not.
I don't think you're taking it far enough. I think there's an even bigger problem, which is like we lived in this beautiful world from maybe 2014 to 2021, let's say, where everybody at the big labs was sharing. We were all writing about what we did. Google comes up with the transformer, and OpenAI builds, the GPT models, and, folks build vision transformers, and just everybody's riffing on each other's ideas. Now that all these big labs are closed up, science is going to move more slowly. Our technology is going to improve at a slower rate. I kind of see that in GPT-4 to a certain extent. When you create a giant ensemble of a bunch of GPT-3s, maybe that's a sign we're out of ideas. Maybe that's a sign that, we need a little more cross-pollination. I'm hoping the fact that leaked, if it's true, will spur a bunch of researchers at other places to try those ideas and come up with something better, and I hope they share. In the same way that, we're trying to share, but, we have correspondence with a lot of other open source groups, whether directly or, simply by the fact that we're all putting things out into the world. The llama models, that was great. Like that kind of pushed forward a different conception of model size versus amount of training. Awesome. That inspired a lot of people. Now people are asking, how far can we push that? Now we're pushing on context windows. Would have been a lot worse if someone had a really long context window and didn't talk about it and didn't inspire other people to push that boundary. Mm-hmm. So I hope with everything we do, we're putting ideas out into the world, and I hope there are other people who also do that. It bums me out that the big labs are going to take and not give anymore. but science is going to slow down because of different cultures at Facebook and Google and OpenAI and Microsoft and everywhere. That interaction led to a lot of the innovation that's happened, and I think that's going to stop.
It's also like the individual researchers and scientists need to ask themselves a question whether or not you should go work to these companies, or come work at Replit or Mosaic or some of the companies who are committed more to sort of open source and collaboration.
I'm certainly getting people reach out. I'm getting outreach now from candidates who are coming from places that have closed up and they want to stay open. And that's an important value to them. I think we underestimate the power of individuals and the commitment of individuals to open science and open source. I'm a researcher. I've got a PhD in this stuff. I wrote a bunch of academic papers. I'm at this point maybe indoctrinated, maybe, I've just convinced myself, but I believe in open source and I believe in sharing. I think that's how the world becomes a better place. And, we don't need OpenAI or Google to do that. We have enough between all of us in the open source community and just the broader enthusiast community to keep things moving in a really impressive way. But we do have to do it purposefully, and we have to collaborate with each other. I think that's really putting together these alliances between all of us. That's where the future is.
I think it would be foolish not to battle open source, especially in light of the past 6 months in the field. Like, there has been an explosion out there of contributors, and the ecosystem has grown by, I think we talk about 3000x in terms of like GitHub repositories focus on anything AI related, both in terms of like main contribution and forks. It's astounding. Like I expected that to an extent, but not to the size that we see today, and it doesn't seem to slow down. Like, again, the San Francisco hackathon scene is completely overwhelming at this point. You get like 2-3 events per day. The new model announcements, I can't keep with that pace. Maybe you, Jonathan, can with your interns.
It's super exciting to see Salesforce in on the game. Like, that's awesome.
Yeah, exactly. That's so. Sure, open source on some aspects is still lagging behind, and people keep asking me, how long is it going to take to catch up? And I always have a couple of different answers. I say, no matter how far we are, even if we move in lockstep and we're, say, 1 year behind GPT-4, who cares? I still know that in early 2024, I'm going to have a GPT-4 model available for cheap for everyone. Or maybe it's going to happen even sooner. So I can start to think of my products based on the fact that that technology is going to become much cheaper. And in light of what's happening in the open source area, I also expect us to catch up even quicker than before, because we simply have more brain power put on this problem. And Mosaic and other companies are helping much more also to catch up. So I don't know. I think there is an infectious optimism in the field right now, which I love. Literally.
There is. I think my biggest challenge is that in the open source world, it's hard to make long-term investments right now. There is kind of a bit of a push to, every company wants to say they can do this. Salesforce just released an awesome model today. It's a 7 billion parameter model on 1.5 trillion tokens. It's, it's the same as, Mosaic released a model, Together released a model, Stability released a model, Llama. We have a lot of great 7B models now. How do we take that to the next level? How do we do a long-term investment over 6 months or a year where someone builds something really, big and different? That's what it takes to really catch these companies, catch GPT-4. It's not something you're going to do in a couple of months and release for a publicity stunt. In the same way, we need really good instruction fine-tuning and chat data sets, not ones that are just scraped off of GPT-4, but really genuinely good human-generated, commercially usable ones. That's a big gap right now. I know it was just announced yesterday that Surge HQ is working with AI2 on their model. And I'm hoping there may be an open source instruction data set that comes with that. That would be a really big deal. But, it's investing in those bigger, longer term artifacts, not the quick hit like, oh, I made the next alpaca data set. That's great. You scraped GPT-4, but we need to think bigger and think longer term than that if you actually want to get a model that's GPT-4 quality that's open source. There's so much more to it than that. I even looked to like the Hugging Face Bloom project as a great example of this, where they did rally a large number of people, had a bunch of people work on different things. And, Bloom may not be a world-beating model today, but it was a really incredible effort at the time. So we may need more efforts like that and less of every company trying to release our own 7B model just to show that, Salesforce also has that capability and Mosaic also has that capability and what have you.
I mean, now that you're under the spotlight, you could be spearheading the new Bloom effort. I'm just throwing there the idea for Mosaic, or maybe together with Hugging Face. But I think, the moment you reach the level of attention that you have now, and of course, you prove to have the capability of making that happen, I think you can rally really a large community behind that. And you can count us in for anything related to code, as you can imagine.
I think the biggest challenge here is, it takes a lot of money at the end of the day. People power are great, but compute is expensive. And, I know to the Bloom project, they got a big donation of compute. I know many, folks at nonprofits like AI2 or Luther can get those donations. I don't think anyone's donating compute to Mosaic, nor do we need it, but, it's still a big check to write. And getting good human instruction data is a really hard thing to do. I don't know whether it's possible to crowdsource that or whether at some point you just have to spend a lot of money to get high quality data. I'm kind of curious, if I were to ask the community for one thing right now, it would be to crowdsource that effort. Can we set up kind of a folding at home type project where a lot of people can supply a couple of answers? You need diversity. So you don't need 10 people doing 1,000 answers each. You need a couple of people having conversations with, conversations that a model might plausibly have put together, and a lot of quality checking. As we've learned lately, it's quality and not quantity that really matters here. But I think that's one of the biggest missing resources if we want to have real, true GPT-4, even Chat GPT-3 quality models.
Yeah, fascinating. Yeah, I mean, we were noticing that, like, when we decided to train the 3B, we truly did that because it's a need. Like, we were going to deploy it like day one, and we did on our product, and it was the best model we could deploy in our product. We only trained it because we knew that, and we reached out to the Salesforce folks to kind of collaborate and things like that. And they had their other priorities, and they're a great team. And now we're seeing people wanting to kind of copy our 3B model, which is like, what's the point? Like, do something new, do something more interesting. And I think I agree with you. This rush to compete on silly benchmarks and just to copy with minor variations is not that interesting, and it's a little fatiguing, to be honest, because there's there's so much churn and announcements that really don't go anywhere. And so what I would like to see over the coming months to year is more directed efforts at actually and also being more product oriented. Is there anyone that is truly trying to match ChatGPT across the board, like ChatGPT 3.5 across the board, coding, all of that stuff? We still don't have a model, despite everything that's happening in open source, that can be said to be ChatGPT equivalent. That you can build a product around tomorrow, and maybe more collaboration would sort of help with that.
Yeah, I also think, the challenge I've given to my team is with every model we release, do something different. Do something a little unique. Like for our 7B model, we released this ultra long context 64K, context window model, the story writer MPT model. That was the result of one of those challenges. Like, do something different and let's see what happens. Let's try, let's build useful models, but let's play with them in interesting ways. For the 30K model, we did a lot of work on the chat data set just to try to understand how do you get a really good feeling chat model and how do you measure it? It's that chat model is really good. Unfortunately, it's not commercially usable due to the origin of the data. But now I have a roadmap for if we as a community could create a commercially usable version of the chat data that went into that model, we'd have a pretty damn good open source, kind of almost ChatGPT-esque quality model. That's super exciting. So I'm going to keep challenging my team every time, do something interesting. Build a model that can actually take a whole GitHub repo and do something interesting with it. Build a really cool embedding model next time instead of building, just a normal generative model. Focus on structured output instead of focusing on unstructured output. There's a lot there. We just need to be willing to be a little bit creative and not just train Llama again for the nth time. It was cool the first couple times. I think at this point, we're now seeing the result of a lot of efforts that probably started a few months ago to train Llama quality models. It just took a while. And nobody's going to hold them back, even if they weren't the first or the second or the fourth to get it out. But now we need creativity. We need a lot of different ideas bouncing around. I'm sure that's what's happening inside the places like OpenAI and Brain. We should be doing that as a community. We have more resources and more people. We have tons of ideas. people should be willing to do weird stuff.
I think we can afford to do that on instruct tuning and fine tuning. It's hard to do it for base models.
Oh, I
Like only
completely
few
disagree.
entities.
I
Okay.
completely disagree. Don't do it on a 7 billion parameter model. Do it on a 300 million parameter model, and work your way up. Like
I mean, but you know that some behaviors are not going to emerge at that scale. Like how are you going to convince yourself that that's a good bet?
At least convince yourself that it's doing something different. I think that's really when I want to play with this stuff creatively. I'm not always looking for is it better, but I am looking for did I get signal? Did I do something that was different enough that this might actually lead to interesting behavior at scale? Often it's different enough in a bad enough way that I know not to even try. But just anything that's different. I think we've got such a, all these models to a first approximation are the same. There are minor differences, like, the Falcon model doesn't say anything bad about the United Arab Emirates. Like, there are different things in these models. But, in general, they're pretty much the same model trained on the same data. And you're going to get the same behavior from all of them. They have slight strengths and weaknesses depending on what was in the data mix. But, there's value in just being different for the sake of being different and trying things. And fine tuning especially is a great way to do this anyway. Like our story writer model was really cheap to train. It was like a couple $100 on top of the 7B model. Well, that was a cheap experiment, but maybe the next model we should actually train to 64K the whole time. Maybe if we see enough there, that's a worthwhile investment for us to make and spend a little extra money to do something really ridiculous. Maybe we should go all in on like really quantizing the model at inference time, like doing 1-bit key value caches and things like that in order to get ultra long sequence lengths on a gaming GPU. Like, who knows? Let's be different. Let's try things. I think that's in the spirit of deep learning where we never know what's going to happen. It's just about getting the cost of experimentation down. And, that's our focus at Mosaic, just driving down that cost.
I have a question on the data aspect of it. Is there more work to do there? Like,
Oh yeah. Oh yeah.
Yeah. Like, can an open source hacker, and instead of contributing to sort of the model architecture or inference, there's a lot of cool work there. But say I don't have a compute budget, I want to be able to contribute and do something different. Maybe one thing I should do is like I could go and like create a high quality data set. Like, what do you think people should be doing there?
Our data sets are complete trash, at least our open source data sets. And I don't say that to insult anyone. A lot of people have put a ton of work into these data sets, but it's really hard work to do and it's unglamorous work. There are certain data sets that we love, like we love the pile, we love the stack. But for every one of those data sets, there are a bunch more that kind of, people put out there and never really get the attention or love they deserve. So it's a bit of a thankless job. Even if you're in academia, nobody gives you credit for building a new data set. They give you credit for building a cool new model that does something amazing. But data work is it feels unglamorous. And so often I think people shy away from it. So we've done incredible work so far, but a lot of our data sets are just old. I don't think my friends at Eleuther would be mad at me if I said the pile's an old data set at this point. It's 3-ish years old now. It was a remarkable data set. And for the time, like I look back at 2021 and I'm like, holy shit, they had incredible foresight to build a data set like that. And honestly, it reflects a lot of the modern best practices. So Stella, everybody else who worked on that, like they did a really fantastic job. On the flip side,
the pile stands the test of time because it's still better than Red Pajama and other more recent data sets, which I find amazing after 2+ years.
I think I completely agree with that. Like I don't know. I look back, like, I don't know, the Eleuther folks are some of the best in the world, and I feel like they don't get the credit they deserve for continuing to do
I agree.
Really fantastic work. Holy crap. But our data sets still have a lot of opportunity. We've started doing this thing at Mosaic where we have a weekly data party. We'll just read a data set. We'll sample examples from a data set. So I think looking at your data is so important. And I've learned so much. Like for one example, I love doing this to compare and contrast data sets. Like Wikipedia is a great place to start. There's Pile Wikipedia and Red Pajama Wikipedia. They were made at very different times. So some of the articles have changed, but many have stayed the same. And then, on top of that, you can go and look at the same, how an article that's still the same was created by both of those data sets. And for example, the Red Pajama data set in a lot of cases only has the first paragraph of the article. That's not to insult the Red Pajama folks. They did great work. It's just hard. And there's a lot of details to get right. The Eleuther version of it, the Pile, is missing anything that's in a table or a bulleted list, which if you look at, say, the article for baseball, it's all tables and bulleted lists. You're missing a lot of information. And my takeaway from that is, oh, we should spend a little bit of investment recreating a Wikipedia data set and then asking what format should it even be in? Like maybe we should put it in Markdown. Like Wikipedia in Markdown seems like a great format for a language model. Let's try that. When you look at Common Crawl, you see like all sorts of interesting variations of Common Crawl with HTML or not HTML, JavaScript, not JavaScript. Even looking at the stack, like we did a little data party where we looked at the stack JavaScript because I think that's kind of an interesting case. JavaScript is really diverse. Most of it seemed to be minified JavaScript, which nobody's going to be writing in practice. So we actually left JavaScript out of our MPT models because I was afraid of that. And I feel good about that choice in hindsight, but we need to filter it. And I'm sure you all thought a lot more about that than we did.
We did a lot of post-processing on JavaScript and TypeScript for our 3D model. We were going through the data parties. I didn't code them in such a cool way, so I should be doing that from now on at Replit. I love it. But yeah, I know the pain of spelunking through data sets. And the truth is, it pays off so much that it's a good reason why you want to invest that amount of time. Absolutely.
Yeah, but that's something that someone in the community can easily do. I'll say I'm very excited to be joining Databricks soon because, one of the hardest things is building good tools to iterate over these massive data sets at scale. And I'm super excited to go to the place that has the best tools for iterating over these giant data sets at scale and be able to do this kind of work easily. I want my scientists to think about science, not about trying to get Spark up and running in our cluster, which is not a fun experience. So, and I'm excited to share what we do with the community. Like my goal at Mosaic is to produce constantly up-to-date versions of these data sets that always have the latest Common Crawl pull and always have the latest version of Wikipedia. Maybe even always have the latest version of GitHub, although I don't know how easy that is to scrape. And just to make sure these resources are constantly available and constantly improving. Those are just good for the community. The pile was amazing. Wouldn't have been cool if the pile were always up to date. I don't know. I think there's a lot we can do.
That would be fantastic. If you can do,
you're announcing this. Yeah, open source is going to be available for everyone.
I'm announcing that we're starting to do it.
Love it.
I don't want to claim that we've got it done before we've got it done, because as anybody who works on data knows, it always takes 5 times as long as you think. Every time I've worked with a customer, with the exception of Replit, everybody schedules their training run, and then we get to about a week before the training run, and they say, actually, I need 2 more months because I'm doing data work. Every single LLM I know of, public, announced, unannounced, has always been delayed by the sheer mountain to climb when it comes to data work. So, I don't want to promise this is going to be available anytime soon, because I want it to be available soon, and that means it's going to take a while. But it is something that we are working on building right now. And I'm very optimistic that if the regulators approve and we get to work with our friends at Databricks more closely, we'll be able to do this a lot faster, because right now I have PhDs in machine learning and neuroscience trying to implement Spark. Not a good idea. Not a good thing.
It's so awesome how aligned Mosaic is with the community, because open source obviously kind of benefits your business directly, and open data does as well, because now you're going to have more customers that can move faster because the data is available. And it's amazing when you see these companies that sort of aligned in a sort of in a positive way, where a lot of the AI labs, the sort of adverse selection effects that are working really hard against them being aligned with the community.
Yeah, I think, it's part of how we set up the company initially. I remember when we had the very initial discussions, and it all started with my biggest fear, which is, I would hate to be the research team that gets fired when, money is tight. And we've seen this happen now at a bunch of companies that have laid off researchers or folded researchers into production. I know my friends at a couple of other AI startups have actually, laid off their entire research teams as startups kind of building MLOps tools or things like that. Because honestly, what good is a research team? It's just a waste of money, and to some extent. And we worked really hard to make sure we built the business around a research team. But to do that, our business can't be that we just discover secret sauce. There has to be some kind of product. There has to be something where, we're not dependent on just selling secrets or selling efficiency. We have to have something we build. And as a nice outgrowth of that, it ended up being that our product is not the model. Our product is the machine. And if our product is the machine, the goal is to drive down the cost of everyone using that machine. I'm a really big believer that, if the cost went down by 10x, the market would be 100x bigger. And the cost going down by 10x means data. It means training compute. It means complexity. It's all of that stuff that goes into it. It's not just, can I train a model? There's so much more than that. And so I'm challenging my team every single day, like, just how do we make this easier? Easier is cheaper. Easier is a bigger market. We make more money, but that's completely aligned with the open source world, where if I had my way, the cost of training GPT-3 would be $100. And you know what would happen if that were the case? People would just train even bigger models. People would just train even more models. Instead of training one model, you train 10,000 and pick the best one or build an ensemble of all of them. At the end of the day, people are still going to spend until they stop getting return on investment. If the cost is lower, that just means there's a higher threshold before they run out of return on that investment.
Absolutely.
Yeah, I think also what open source is revolutionizing at this point, and where I see a lot of energy, is the work being done on inference. Everything on the GGML side, we are extremely hyped about it. I know that you guys are Mosaic are also building your inference infrastructure. Very thankful about that, because whoever has tried to put an LLM in production knows how that end-to-end experience is way more painful than they would expect. So yeah, why don't we spend the last few minutes of our panel talking about inference, and also let's touch upon the model size choices. Like, respectively, our 3B and your 30B, those numbers are not there by chance. We picked them for a reason. So let's start from the 30B, which is the most recent.
So the 30B, that number is actually very intentional. It was chosen for two reasons. One is that if you follow Chinchilla, that's about how you get to GPT-3 quality. That's approximately the target, somewhere between 30 and 33 billion parameters. The other piece is that, at least with our setup, that was how you get to doing inference on a single GPU without having to go to crazy low precision or do other stuff, at least with a reasonable sequence length. And we have an inference product now. And the amazing thing about that is I have people who I can now talk to and say, hey, is this going to work on inference? And they're like, no. I'm like, hey, is that going to work on inference? Maybe. Hey, what's the biggest model that I can fit on a single GPU before I get into trouble? And they can answer that question, then we co-design. So as we think about MPT-2 and MPT-3, we kind of want to keep having a new family of MPT models every few months with all the best innovations that we have. The first thing I ask after will it work for training is, will it work for inference, or what do we have to do to make it work for inference? I kind of have this dream that maybe distillation will pay off, and we can actually keep the same MPT architecture for inference the entire time and do crazy things for training that we can distill into that, so that we can separate inference and training. But until they're separate, we have to take into account both. And so now I get to ask the question back to you. So why'd you pick 3B? Why not 1B? Why not 100B? Like, why'd you pick 3B?
That's a great question. And as you recall from our experience, I was always obsessed by every single detail up, to the inference, which paid off. Otherwise, I don't think that release would have happened on time. Amjad, I'm not planning to give you a heart attack on the panel, but there were so many things that could have gone wrong that didn't, which I'm very grateful. 3B wasn't by chance, of course. I think we started from an ideal latency number we had in mind. We wanted to be around the 200 milliseconds threshold, which for a human gives you basically the impression of immediate response. And then we did some ablation testing on A100s. So we didn't have H100s available back in the days. And that, we knew that with that model size and the custom vocabulary that we train and everything put together, we would have been able to strike the number. I think as of today, we are 250 milliseconds P95, which I feel it's an amazing result.
Yeah. And
we did some testing on H100s, non-optimized, as you know, because there's really nothing out there that is squeezing all the performance at the inference time on H100s. If I recall correctly, we are 30-40% already faster than the standard inference on A100. So the hardware is improving. I'm already extremely happy with the inference latency we get on the current A100s. And that's also the reason why we're targeting larger models at this point. So our model size is always functional, the latency that we want to put in front of our users.
So I think the important thing we should talk about offline is it's not just model size anymore, but model shape is going to matter. Changing the model shape internally, we're seeing improvements in utilization of the GPU from like 30% to 60%. And so it's entirely possible that
wide instead of deep, right?
Yeah, wide instead of deep, because the H100s are very wide. So it's entirely possible your next model could be, let's call it a 15B model that has a very weird shape, that allows it to still get the same throughput as the 3B model because it's better utilizing the H100. So, we should chat about that offline, but I'm kind of excited about that possibility. Maybe we can go bigger than, not just bigger because the GPU is faster, but bigger because the GPU is wider.
That's fascinating. Yeah, that I haven't thought about that at all. I mean, first time I'm learning about this. This is very cool. Would love to learn more. There's also a sense in which we have this plan of open sourcing it, right? Like, look, Replit's goal is to like make software development easier, simpler, fun, more accessible. Our business is not going to succeed because we have the sort of incrementally better sort of model, and so we also open source it because we want this technology to be accessible. You shouldn't have to pay $10 for Copilot in order to get access to code generation. And 3B also felt like portable enough. I didn't know, we didn't know it at the time, but now people are like able to run the 3B locally with 2 gigabytes of RAM, which is like a computer from 10 years ago would be able to run it like comfortably. And now people are using Replit code model locally as a replacement for Copilot. Some people instruction tuned it, and now they have a local sort of code assistant chatbot. And again, those don't really advance our business a whole lot, but again, it's really fun to see just the community hacking and playing with it. So that was a consideration for that. And also, just to credit the Salesforce folks, like the CodeGen, we tested the 300 million, the 1 billion, the 3 billion, the 6 billion, the 12, all of them. What's interesting is the 3 billion was like a really nice sweet spot. Like I think so. They sort of accidentally sort of arrived at like llama style, like training a lot
back in the days.
Yeah, because they trained the same tokens across all the different sizes, and I don't think that was intentional, but it ended up, the result was such that the 3B model was such a sick, nice, sweet spot there. And we're like, okay, this works, because we had all these convoluted plans before of like, having a 1 billion Python model and like 4 billion like JavaScript, HTML, like long tail language model, and like all this stuff. But like just the elegance of a 3 billion parameter model that performs well across the board and is also open sourceable, you can run locally, was really a nice sweet spot at the time.
Yeah, the nice thing is that I think a lot of stuff that works well on H100 may also work well on CPU, because really wide models you can take advantage of on CPU because you have a lot of memory. So I'm kind of, and I don't know, my whole dissertation was on neural network pruning, which is absolutely useless. Both my dissertation and neural network pruning. I can say that now that my diploma arrived in the mail last week. There was a parchment shortage, so I finally have it. Now I feel safe saying that. My advisor is no longer in the office, so I can get away with that one. My dissertation was kind of useless on that end. Pruning works really, really well on CPUs. Our friends at Neural Magic, for example, have really pushed that. The folks at Intel are really pushing that. So I'm kind of optimistic that without too much trouble, we may be able to get a model that, is weird shaped for H100s and is easily adaptable for CPUs, and do some really cool stuff there. Like the folks at GGML who are doing incredible work on that front. For the most part, they're just taking models off the shelf and quantizing them. There's so much more we can do, and I'm really excited. I know we're up against time, and my salesperson's about to drag me away because customers come first. So any final things you want to do as we wrap up?
No, Jonathan, I wanted to thank you. It's been a pleasure to chat. I know we do this regularly between us, but doing it with Amjad and in front of everyone has been amazing. I know that we have a long list of questions that we didn't have time to address from the attendees. We'll take care of that on Twitter. I will tag each one of you so that we can reply to our community. Thanks again. Good luck with your next steps at Mosaic plus Databricks. We're excited to work together. And thanks, Amjad, for attending. And we'll see you soon at the next installment of the Replit AI panel.
Thank you, Jonathan.
So much. And for anyone who's on Twitter, at me and I will respond. I promise you that.
I can testify that.
Awesome. Take care.
Bye.
Take care, everyone. Bye. Bye-bye.